Breaking news: how traumatic brain injuries reshape social cognition. The case of Aaron Hernandez and more.
When people think of traumatic brain injuries, or TBIs, they often envision a single event, a violent hit on the football field, or a terrible car crash. But what happens after the cameras stop rolling and the headlines fade away? How do repeated head impacts to the brain quietly alter a person's emotions, social judgment, and even their morality? Hi, I'm Madison Boges, and today we are going to explore how damage to various parts of the brain, like the insula and prefrontal cortex, shapes our ability to trust others, respond to unfair situations, and regulate our own behavior. We'll start by examining a highly publicized case, the former NFL star Aaron Hernandez, whose tragic story may be linked to a severe form of brain injury, acquired after years of repeated blows to the head. Aaron Hernandez was living the dream. Hernandez, from a young age, worked tirelessly to become a professional football player, catching the attention of top collegiate programs and eventually the New England Patriots. On the field, he became a household name, a rising star, but off the field, a darker narrative was unfolding. In 2013, seemingly out of nowhere, Hernandez was arrested and later convicted of multiple murders. To friends and family, it was shocking. How could someone go from the pinnacle of professional sports to such violent acts? When Hernandez died by suicide in prison, his family donated his brain for scientific study. The results were staggering. He had severe chronic traumatic encephalopathy, or CTE, a degenerative brain disease associated with repeated head traumas. Suddenly, the narrative shifted. Was it possible that his brain damage altered his behavior, his capacity for rational thought, and even his perception of social norms? Understanding cases like Hernandez might help us prevent future tragedies. Next, we're going to hear from Dr. Lederman about the underlying effects of head trauma.
Hi, I'm Daniel. I just want to debrief what is traumatic brain injury. So TBI is a sudden trauma from an external blunt force that causes damage to the brain. There are a couple levels of traumas. Mild TBI, which result in a concussion or subconcussive state with no apparent brain damage. Usually, there are no or brief loss of consciousness and altered normal brain function. Moderate and severe TBIs result in significant neurobiological and cognitive impairments, usually causes loss of consciousness for 30 or more minutes, and could result in cortical lesions and skull fractures. Here are the papers we reference throughout the video. To grasp how TBIs can impact social cognition, return to research models. This study, repeated mild head injury leads to wide-ranging deficits in higher-order cognitive functions, use repeated mild TBIs in mice, simulating the kind of repetitive impacts an athlete might experience. It investigated how repeated TBI affect complex cognitive tasks linked to prefrontal cortex, such as social behavior, decision-making, and working memory. After multiple hits, the mice didn't show dramatic anatomical damage on MRI. No major structural changes in the cortex, hippocampus, or white matter, but behaviorally, something had shifted. Mice usually prefer to be in an enclosed space because they are more safe. However, the mice with repeated TBI showed behavioral disinhibition. They took more risks, spending more time in the open arms of an elevated maze, where normal mice were more cautious, spending less time in the open field. When the subject mice were in an arena containing mice they previously encountered and the new novel mice, the repeated TBI group explored the new mice less than the control group, meaning they struggled to distinguish a new mouse from one they previously encountered. Their capacity for social recognition had diminished. The repeated TBI mice took longer to escape the learned maze compared to the control group, meaning tasks involving spatial memory became harder, slowing their ability to learn and adapt. Beneath the surface, the researchers found evidence of inflammation in the medial prefrontal cortex and subtle changes in neuronal adaptation. While there was no blatant structural damage, the brain's delicate circuitry and chemical balance had been disrupted. These subtle changes in the prefrontal cortex, a region tied to decision-making, impulse control, and social behavior, help us understand how repeated minor injuries can accumulate into profound behavioral shifts. We have seen how traumatic brain injuries to the prefrontal cortex affect behavior in mice, so now we'll discuss a couple studies on how brain injuries can alter our social cognition. Trust is a huge part of our lives, especially in building meaningful relationships. It depends on reading others' intentions, responding to fairness or unfairness, and managing risk. The insula is a key brain region for internalizing emotional states, predict risk, and detect norms violations, a process critical in social exchange. One study hypothesized that damage to the insula will lead to abnormal patterns of trust and reciprocity. The study comprised of 3 groups of participants. The first had a focal insular lesion, meaning damage mainly to the insula. The second was the brain damage comparison with no insula damage. And the third group were neurologically normal controls. To test their hypothesis, they measured reciprocity and trust with the behavioral economic trust game. Here's how it works. There are 2 roles in the game, an investor and a trustee. The investor is given a fixed amount of money, let's say $10. The investor can choose to keep the money or invest any portion of it with the trustee. Any money invested is tripled. For example, if out of the $10 they receive, the investor gives $5, it becomes $15 for the trustee. After receiving the tripled amount, the trustee decides how much money he wishes to return to the investor and how much to keep for themselves. They are not obligated to return anything, so they can keep all the money if they wish so. The game explores the investor's willingness to send money, anticipating the trustee will return some of it back, which measures trust. The trustee's decision to return money based on the investor's trust measures reciprocity. The outcome shed light on how people balance personal gain with fairness and social cooperation. All participants played 20 rounds of the trust game, first as investors, then as trustees. They played against a simulated opponent, and the researchers tracked their strategies and earnings. Here are the 4 strategies measuring reciprocity and trust. Tit for tat matches partners' change in investment or returns, which reflects normal mutual trust. Benevolent invests more even if partner invests less. Malevolent decreases trust and invests less even if partner increases investment. Ambivalent, no change regardless of partner's behavior. The study assessed how often participants adopted these patterns and how insula damage influenced these choices. What they found was remarkable. Normal controls typically relied on a fair reciprocal strategy, tit for tat, when trusting and being trusted. Brain damage comparison group showed some deviations from perfect reciprocity, but remained somewhat balanced. Insula damage group displayed strikingly abnormal trust patterns. As investors, they were overly benevolent, failing to reduce their trust even when others exploited them, tying insula function to risk evaluation and social norm conformity. As trustees, they were more malevolent, betraying trust unexpectedly. This pattern disrupts cooperation and signals an inability to follow social norms, crucial for maintaining beneficial relationships. In other words, damage to the insula disrupted the delicate balance of give and take. Without the proper functioning of this region, these individuals couldn't read social cues or adjust their behavior accordingly. They trusted when they shouldn't, and they broke trust when it made little sense. This underscores the insula's central role in guiding our social radar, helping us know when to trust and when to protect ourselves. Next, let's consider the ventromedial prefrontal cortex, another region crucial for evaluating future outcomes and navigating complex social exchanges. One study looked at how ventromedial prefrontal cortex damage affects how people respond to unfair financial offers. They investigated how this area encodes subjective value of future outcomes and social information during economic decision using the ultimatum game. The ultimatum goes as follows. The participant wait for an offer made by a partner. They then see the offer and have a decision to make. Either they accept it and receive the payoff, or they reject it and both the partner and the participant receive nothing. There were 3 groups of participants: selective ventromedial prefrontal cortex lesions, damage sparing the frontal cortex, and healthy controls. These participants were matched with 3 kinds of partners. Human opponent treatment offered a future payoff which resembled an abstract future reward. Human opponent with cash offered the cash in an envelope, which the participants received immediately. This resembled an immediate tangible reward. Lastly, there was a computer opponent treatment, which was similar to the human opponent treatment, but the only difference is that a computer generated the offer. This treatment differentiated valuing social information, a computer versus a human. Under normal circumstances, people might accept unfair offers from a human less than from a computer, because we naturally assign social value to human interactions. We understand that a human is choosing to be unfair, prompting anger or moral outrage. But ventromedial prefrontal cortex damaged individuals failed to make that distinction. They accepted unfair offers at lower rates, regardless of whether they came from a human or a computer. When the reward became more immediate and tangible, their acceptance rates were similar to the other groups, suggesting that the VMPFC is particularly important for valuing abstract, future-oriented rewards and integrating emotional and social considerations. This failure to differentiate between human intent and machine randomness points to a loss of nuanced social valuation that typically guides our behavior. While all groups were able to label the fairness and anger levels of the offer in similar fashion, the physiological responses to unfair offers were significantly higher than responses to fair offers in the normal controls, but not in the ventromedial prefrontal cortex group. They lacked the normal emotional response patterns, like heightened physiological reactions to unfairness, and as a result, made decisions that seemed irrational, no matter who they played against. To conclude, ventromedial prefrontal cortex damage alters the subjective valuation of abstract or delayed monetary outcomes. It plays a critical role in assessing the social components of economic exchange. Individuals with ventromedial prefrontal cortex damage exhibit diminished emotional responsivity, indicating that emotional state is not the primary factor behind the high rejection rates. The human brain is super complex, and as we showed, damage to particular brain areas alter particular behavior, such as social cognition. Damage to other brain areas will result in different kinds of abnormal behaviors. For example, murderers have shown to have dysfunction in the prefrontal cortex. Amygdala damage affects predicting social fear in others, and orbitofrontal cortex damage affects the inhibition of aggressive impulsiveness. Therefore, instead of further exploring how damage to specific brain regions affects specific behavior, Professor Boges is going to discuss how the overall damage from traumatic brain injuries alter the overall behavior on social valuation.
Thank you, Dr. Lederman, for that enticing information. Now, so far, we illustrated how damage to specific brain areas in adults and mice change specific behaviors. But what about younger individuals who sustain traumatic brain injuries during critical developmental periods to their overall behavioral impact? Studies show that school-aged children with severe traumatic brain injuries often struggle socially. They're rated as less socially competent and lonelier than their healthy peers. Over time, these problems can persist, affecting social and emotional development, which may lead to a decrease in social value. To understand why, researchers use models like Crick and Dodge's Social Information Processing Model, or SIP. The SIP model breaks down how we interpret and respond to social cues. After a traumatic brain injury, adolescents might develop maladaptive social information processing styles, either overly aggressive or overly passive, to social challenges. Essentially, a traumatic brain injury can derail the normal learning processes of reading social signals, leading to a lasting issue in forming relationships and participating fully in social life. Now let's look at this study on social competence and behavior in children to identify the problems that may arise for a child who has experienced a traumatic brain injury. The objective of this study was to examine social information processing skills, behavior problems, and social competence following adolescent TBI, and to determine whether social information processing skills were predictive of behavior problems and social competence. Adolescents aged 11 to 18 with severe traumatic brain injury and moderate traumatic brain injuries were injured up to 24 months prior to the recruitment of the study. The participants and their parents were asked to do 4 questionnaires to measure the behavior of the child. So they were measured on SIP skills, the Child Behavior Checklist, which is a parent-reported measure of behavior, a youth self-report, which is self-reported measures of behavior by the child, and a home and community social behavior scale, which is another parent-reported behavior measure. Now let's look closer at some of the data from this study. This table looks at SIP aggression as a predictor of externalizing and social problems. As we can see in the red squares, there was a significant difference between moderate and severe traumatic brain injuries and the Child Behavior Checklist, all externalizing measures. The SIP aggression score was also a significant predictor of the social Child Behavior Checklist scale, externalizing problems, and the youth self-report externalizing problems, and the child behavior checklist social problems. And these results are shown in the bottom 3 red squares. This table looks at SIP passive composite as a predictor of social competence. As we look in the 3 squares, in the middle, we can see that there is a significant difference between moderate and severe traumatic brain injury and the youth self-report for social groups. Additionally, as we look in the last row, the SIP passive composite was a significant predictor of the youth self-report social subscale and the home and community scale for peer relations. Lastly, this table looks at social information processing passive composite as a predictor of internalizing and social competence. As we look at the bottom row, we can see that the SIP passive composite was a significant predictor of the Youth Social Report Internalizing Problem Scale and the Child Behavior Checklist Social Problem Scale. Overall, in comparison to adolescents with moderate TBI, those with severe TBI had significantly more parent-reported externalizing behavior and self-reported weaknesses in social competence. Additionally, an aggressive social information processing style predicted externalizing problems, and a passive social information processing style predicted internalizing problems. Both passive and aggressive skills were related to social competence and social. What if you've experienced multiple concussions over many years? A study of former collegiate athletes found that those with a history of repeated concussions were at significantly higher risk for depression, impulsivity, and aggression even decades after they stopped playing sports. The data showed a clear trend. The more concussions reported, sport-related or not, the higher likelihood of mental health struggles later in life. The purpose of this study was to estimate the association between recurrent concussions and current level of depression, impulsivity, and aggression in a cohort of former collegiate athletes. There were 797 athletes played at least one season of a collegiate sport at the host university between 1987 and 2012, aged 18 and older, and they all have recently had concussions. This time, 3 questionnaires were given to the participants to look at the mental health. The first measure was the depression module of the patient health questionnaire, then the short form of the Barrett Impulsive Scale test, and the 12-item short form of the Bus-Perry Aggression Questionnaire. In this study, we will see that the effects of having recurrent concussions through sports can have detrimental effects on your mental health. Some examples of effects that can happen are impulsivity, Alzheimer's, CTE, depression, and aggression. CTE and Alzheimer's are a long-term effect of repeated head trauma, so they're more difficult to measure. Therefore, today we will be looking at the severity of impulsivity, aggression, and depression in patients with multiple concussions. The first table shows the distribution and mean values of mental health outcomes by self-reported total concussion history in patients. What I want to highlight in the red squares in this table are the means of depression, impulsivity, and aggression testings for respondents that reported 0 concussions and what their scores look like relative to the participants with 3 or more concussions, which are in the far right red squares. Table 5 is showing us the prevalence ratios and prevalence differences of depression by self-reported total concussion history. Controlling for alcohol dependence and family history of depression, the prevalence of moderate to severe depression among former collegiate athletes is reported 3 or more times of having a concussion in total was 2.5 times more than that of a former collegiate athlete reporting 0 concussions, as you can see from the top row of red squares compared to the bottom row. This table looks at the mean differences in impulsivity and aggression by self-reported total concussion history. This again is controlling for covariates like alcohol dependence, family history of anxiety, and more. And it was seen that former collegiate athletes reporting 2 concussions in total had higher mean scores for impulsivity compared to those reporting no concussions, as we can see in the red squares. And while you're controlling for alcohol dependence, sex, and relationship status, former collegiate athletes reporting 3 or more concussions in total had a higher mean score for aggression compared to those reporting no concussions, which is seen in the bottom half of the red squares. This table looks at prevalence ratios and prevalence differences of depression, but only for former college and professional sport athletes with a concussion history. And as we can see, comparing the top row of red squares to the bottom row, there is a significant difference in the depression levels of participants, with 0 compared to 3+ concussions. And lastly, in this table, we can compare the mean differences of impulsivity and aggression, but only, again, for former college and professional sport athletes with a concussion history. And as we can see again, participants with 0 concussions in the upper rows, compared to participants with 3 or more, shows a significant increase in their scores. In conclusion, the link between repeated head injuries, aggression, impulsivity, and depression over time suggests that repetitive head trauma doesn't just affect immediate decision-making. It can alter the trajectory of a person's mental well-being. It can alter social integration, well-being, interpersonal functioning, many things. Our social world is built on social subtle cues, trust, and understanding. When the brain's networks are disrupted, those foundations can crumble. But with advancing science, education, and responsible care, we can ensure that traumatic brain injuries do not define a person's fate. Instead, that can become a starting point for healing, empathy, and informed action.
Thank you for watching.